Now, yes.
Yeah, okay. Now, today I will complete the remaining part of 3D meshing. See here, it is very interesting. You can see here. You will see here, if you start the practicing, then you will get the interest in it. Okay. Now I will open the model. See here, I have opened this model. It is a 3D model. Now it is, you can see this one is, I will change the color. This one is 3D geometry, and if it is 3D geometry, then your lines are bold. Okay, it is not surface geometry. Now the functions which I am going to teach today, that we can use on only 3D geometry. Okay, not on the 2D. Now in 3D,
Hello, sir.
yes,
हा सर, ही 3D फाईल सर कशामध्ये क्रिएट केलेली आहे सर?
this 3D file I have created in the CATIA.
ओके सर.
I have created, just minute, I have created in CATIA. Then I have saved it as a IGS file, and already I have shown you how to import the IGS file. Okay, and
ओके सर. ओके सर.
why I have opened in or why I have opened as a HM model, because on model we cannot upload IGS files. Okay, I have tried it, but I could not get the result. That is, I could not upload the IGS file. That's why I am going to upload HM files, but that are geometries. Okay, now this is a 3D file. This is 3D file. Now in 3D, here I have explained a drag, spin, a linear drag, element offset. Okay, and in that I have explained the linear solid also. Now I will go to the solid map. This solid map. Okay, it is very important menus in hypermesh, and because of these menus, this software is very good for meshing. And one more thing I want to tell you here, here you will get the good quality mesh, not necessary to check the quality also. Okay, but for that purpose we need mappable solid. Mappable solid means what, that I will explain first. You see here, here in Atto, if I change from this Atto to mappable, it is in the form of dark color. Okay, it is in the form of dark color. Okay, dark brown color. Now if you see the meanings of visualization, I have clicked on this icon, visualization. Okay, visualization option. Now here in 3D, in 3D, see here, for 2D we have discussed this. Okay, and in 3D, below this, you see here, here mappable, if you get this transparent color, this type of transparent color, I will show you when I make it mappable. This is known as a one directional mappable. Okay, and this is three directional mappable. Okay, and this one is ignored. Okay, this is not necessary to, or this will not, or this cannot be changed to the mappable. Okay, and this is not mappable. You see here, this color is not mappable. That means your geometry is now not mappable. Okay, now we can convert not mappable geometry to the mappable geometry by using the editing geometry tools. Okay, editing geometry tools. Now how we can do this, I will show you. You see here, mappable means what? Mappable means meshable. Meshable means we can put the hexahedron blocks. That means automatically we can put the hexahedron blocks. That means we can simplify the geometry. We can simplify the geometry, and in ANSYS it is sweepable body. It is sweepable body. Here it is known as a mappable body. Okay. How we can do this, I will show you. Now for that purpose, I will go to the geometry, and see here in editing, I have shown you different options of the solid editing, and that by using that options we can uh, make the mappable solid. That means we have to split. That means in surface meshing, how we can split the surfaces, that I have explained you. Now in solid also we have to split the solids into different parts so that we can get the mappable solid. Okay. Now how I can do it, I will show you. Now go to solid edit, go to solid edit. Now see here, you see here, this is a simple geometry. This is simple geometry. It is not that much complicated. Uh, how we can modify this, and by modifying this, how we can get a mappable body, that I will show you. These options I have already explained, that is trim with the nodes, trim with the lines, trim with the planes, merge, okay, boolean operations, that also I have explained. Now by splitting the solid, that is by trimming the solid into different components and different regular geometries, we can get the mappable solid. How we can do this, I will show you. So here you first uh, understand this geometry, you study this geometry properly, then you start the converting that to the mappable geometry. Okay. Now see here, there is one block, here there is one block, and if we take only this block, that means this part, this cube, this cube, then it will be mappable because it is a regular symmetric geometry. Now when we take this one, this is also mappable. Okay. And this is a cylindrical uh, rod or cylindrical part. That cylindrical part is also mappable. That means when we consider only separate part, that is also mappable. Now here from these lines or about these lines, this is the what we can say hollow cylindrical part, that is half cylindrical part. Okay. And that half cylindrical part is also mappable. Okay. But when it is taken separate from this whole geometry. Okay. Now this bases, these are the two cubical shape, that is what we can say simple cubes. Okay. Now that also mappable, or simple blocks, that also mappable, but when we take that out of the uh, complete solid. Okay. Now the whatever things I have told you, that you do in solid editing, that means you take this as a separate part, that means you split this part here at this location, you will get this as a mappable. You take this cube at this location, that means you break this solid at this location, that you will get this part as a mappable. You break this cylindrical part at this location, that will become a mappable. Now this part, this complete part, you break at this location, you will get these two mappable parts. Okay. How we can do this, I will show you. Now I want to break at this location. Now go to the trim with plane. That means here you can use any option here, but better way to use simplified options. Okay. Now I want to split this part from here. For that purpose, I will cut this solid by this surface at this location. Okay. So I am going to select this trim with the plane or surface, select the solid, select the solid, this solid, it is a complete solid, you can see here, it is complete solid. Now select the cutting surface, select the cutting surface. Now I want to cut at this location, that means I want to trim at this location. Okay. Now this is a cutting surface, I will trim it. Okay. Now it is now this solid and this solid, these two solids are different solids, you can see here, this solid is different and this solid is different, but it is no any solid is mappable. Okay. So what I will do now, I will split this solid, that is this is cylindrical and this base rectangular, this solid into two parts, that means into three parts, we can see. Now how you can do this, I will show you. I will go to the trim with lines, trim with lines. Now here if you observe this one, here these lines are bonding lines. If these lines are not there, you can create the lines by splitting the surfaces. Okay. You can create the lines by splitting the surfaces. You can create single line and you can uh, cut by using last option, by using sweep line option. Here we have line around the all surfaces of this solid, therefore we can use bonding lines. Okay. Trim solid with bonding lines. Okay. Now select this solid, select this line, this line, this line and this line. You can see here this is a bonding line. Okay, it is bonding to this solid. Now here it will form a cutting plane at this location, and it will divide the solid in this part and this part. Now here I have not used the extreme extend trimmer because I don't know whether this location and this location is at same level or not. So I have not used the extreme extend trimmer. Okay, I want to trim only this part. If we use extend trimmer, you can split this part as well as this part. Okay, do you agree with this? But this line location and this line location may be different, may be same. In this it is same, but uh, you can do it by extend trimmer also in single step. Now I will trim it. Now you can see here, color of this block will be changed. Color of this block is changed. Why it is? It becomes one directional mappable. One directional mappable. Have you got it? Now same thing I will do for this one. This one lines, this line, this line. It is a bonding line. Okay, and say trim. Now you can see here. Here this becomes a green color. Green color means three directional mappable. That means you can start the meshing from any side. And one more thing, when we want to use multi-solid meshing, that means when you want to mesh the multiple solids, then at least one solid should be three directional mappable. Okay, three directional mappable, and remaining solids should be one directional mappable. That means if we go to this 3D meshing solid map, in solid map there is a multi-solid option, that is meshing of multi-solids. Now when you want to use this option, I'm going to use this option today in this. Okay, in when we want to use multi-solid option, then at least one solid should be green in color. Green in color means it is a three-dimensional mappable. Okay, and remaining solids should be like this. That means one directional mappable. Okay, now remaining solids should be like this. That means one directional mappable. But in this geometry, these parts are not mappable. Okay, now we have to convert these parts into mappable parts. Now I will go back to the geometry edit again. Go to solid edit. I will select this one, this solid. Okay, I want to trim at this location. So I am going to use other option, that is trim with surfaces. This one, surface at this location, trim. Okay, now this you can see here, this cylindrical part becomes transparent, means it is mappable. Now this part is not mappable. Now for making this part mappable, you break this solid into two or three parts depending upon the requirement. Okay, now again I will use this same option. I will select this one, this surface. I am going to trim at this location. Now this part becomes mappable, but this part is not mappable. Now for making this part mappable, what you have to do, you again go to this one and say surface this one. Okay, now you can see here complete domain is becoming mappable. Any doubt here? If you have doubt, you can ask me. Yes, Indrajit Mohite, if you have doubt, you can ask me. Kunal Patil, if you want the repetition of this once again, then also I will explain. See here, I am going to take two or more problems. Okay, but if you have problem in understanding the concepts, you can ask me. You check it. Yes, can I go for next? Kunal Patil, no reply.
Sir, have you uploaded that model on Moodle, sir?
Here, I'm going to upload this one. Now you want.
No, sir. I was just trying to imitate you.
Immediately. Okay, I will upload and I will repeat again. Okay, just minute. Give me 1 minute. I will open the RIT. Wait for few 1 minute. So this is geometry file, and just minute. I will check the name of this. Solid map explained na. Okay, I have uploaded it. Okay.
I will
Now
check, sir.
is it necessary to repeat once again this one? Yes or no? Is it necessary to repeat it? Yes. Okay, I will repeat it. Okay. Now what I will do, I will merge all the solids and then I will again go to this one. Merge. Okay. Now first you watch this, you see here. Now you want to convert this into regular geometries, that is symmetric uniform geometries. Okay. And on which we can uh, fix the small blocks, small hexahedron we can fix. Okay.
Sir,
So
it's
you
still
go,
not there.
yes.
It's still not there, sir. Solid map, na? Experiment.
Solid map. Is
No,
it
sir. Tab is not visible.
okay? You check it. I will upload. I will here from my side. It is uploaded. Okay. Okay. I have uploaded on here. Okay. Now you check. Now listen here, Kunal Patil. Then you can do it. I will share the videos also. Okay. Now go to the solid edit. Now trim with the surface first. Select this solid. Now I will select uh, trim at this surface. Trim. Okay. Next I will trim with the lines. This solid bonding lines. This one. This one. This one. This one. Trim. Okay. Next I will select this again. This line. This line. This line. And this line. Trim. Okay. Now I will go to the trim with the surface. I will select this surface. I will trim at this location. Now again I will select this surface. I will trim at this one. Okay. Next again I will select this one. I will trim at this surface. Okay. Now you can see here. See here, if you have okay, I will start the meshing now. If you have this type of solid model, now from where we have to start? We have to start the from complicated location. Now according to this geometry, this part is having hole and this part is more complicated as compared to the other ones. Okay, this part is more complicated as compared to other ones. Okay, so I will start at this location. Now see here, direct 3D meshing, it may result in bad quality of elements, so you can take the help of 2D meshing also. Okay, now I will go to the 2D auto mesh. I will mesh first this surface. Okay, this surface and mesh. Now see here you can use, see this I have 10, I have taken here 10 element size. Okay, now there are lot of triangles, you can remove that triangles. Now how we can remove that triangles, I will show you. Now here there is no triangle, but at this location there is triangle, at this location there is triangle. Okay, how we can remove that triangle, I will show you. Here you go to the remeshing it, go to the, in place of surface you select the elements. Now you select these elements. Okay, and say mesh. Now here there are two elements, I will make it 2 and you will get this removal of this triangle. Okay, that triangle is removed. Now next one, this also I want to remove, this one, same mesh. Here also I will do, I am going to remove this element. Okay, now one thing I want to tell you here, you have what you can say, you have element shape like a diamond shaped elements are not acceptable. Okay, diamond shaped elements, so you can modify it by meshing like this. Okay, mesh. Now here I will change to 3, here also I will change to 3. Okay, okay, I will accept this. Now I want to remove this triangle and this also. Now what I will do here there is one option in 2D edit elements, and in edit elements you can edit the individual element also. Now I will go to the split, this one, split elements, this one, this one, this one, this one. Okay, now how we can split this? Click on points, click here and drag one line like this, you can see here, like this, and say split. Now it is splitted, you can see here, it is splitted. Okay, now here there are two triangles, back to back triangles, that we can combine. You can see here, combine this triangle and this triangle, you will get one chord element. Now you want to remove this these triangles, back to back triangles, also you want to remove these triangles. Now go to the 2D again, auto mesh, you select this one and mesh. You can see here we have removed these triangles also. Now here also you do this same thing, and I will do here 3 mesh. You can see here we have removed the all triangles on this side. Now after that you can do the smooth operation. Number of iterations are 10 I will keep, and I will select these elements and say smooth. You can see here you will get the good quality elements. Okay, have you got it? Now here I want to remove these triangles. Remove these triangles. Same thing you do here. You can see here, go to edit elements, split. Okay, these three elements I want to split. Okay, and click on points. You click here, drag one line up to here. Okay, over and say split. After that, you go to combine. You combine this and this one, this and sorry, this and this one. Okay, you can see here all triangles are removed from here. Now smooth it here. You can see here you will get the good quality mesh. Have you got it? I have created the good quality 2D elements. Okay, now I will go to the, I want to convert this to 2D to 3D. Go to 3D. See here a lot of options we have seen here. Solid edit. Now I will select the one volume. Okay, now here I don't want to give the source uh, surface and destination surface. I want to direct a mesh this solid, and I will go to the mesh. You can see here this, sorry, here there is a reject number of elements, here, density of the element I will select. I want to make the 5 elements on that and say mesh. You can see here you will get the good quality 5 elements, and same pattern you will get on this side also. Okay, have you got it? Without any effort. Or next, same thing you can repeat for others. This one, suppose mesh, reject. Now I want to make 10 elements. Okay, it is not meshing like this. You can use multi-solid also. Multi-solid. Now I will do meshing of this one and this one. Meshing of these two. Okay. Now I'll go to the mesh directly. Here not necessary to select the source geometry, destination geometry. I have selected this solid, mesh. Now okay, you can see here you will get one number. Here you will get one number. Now I will change it to the, here size should be changed. I will make it 5. Okay, this one and this one, mesh. You can see here. Now here you will get the numbers, and on the basis of these numbers you can adjust the size of elements. Here 1 2 3 4 5 6 1. So I will make it 6. Okay, and on this side I will reduce the size. Okay, 4. On this side, here 20 is there. I will decrease this. Okay, 11 or here 2. Okay, over. Now you can see here also you can change the size. I will keep this size as it is, and here uh, we cannot get all, what we can say, all rectangular elements. Some triangular elements may be there. Okay, and say mesh. Now here there is a problem. I will reject it. I will change the size at this location. Here also. Okay, the mesh. Now you can see here, you will get the good quality mesh. Here some triangles are there, but that triangles we cannot avoid. Okay, you can see here. Again, I will reject here, and on circle you can reduce the number of elements. Okay, say mesh. You can see here. Here these triangles are acceptable triangles. Okay. Here it will not disturb the quality. Return from here. Have you got this? Any doubt here? Have you got it? Any doubt? Dheeraj Chavan. Dheeraj Chavan, have you got it?
Yes, sir.
Okay. Again I will show you multisolid. Multisolid. Here. Now I will select all these solids. This one, this one, this one, this one. All these solids I have selected. Okay. Now I will mesh it. Mesh it. Now you see here. Here it will show the surface mesh, and on the with the reference of this surface mesh, you can see here this is surface mesh. Now there are a lot of triangles. You want to remove the triangles. How you can remove the triangles? See here we can make 0 triangle. You can see here. You click on this line. I will click on this line. You will get one number here, 94. You click on this line. You will get number here. You make equal number of divisions of this line and this line. Okay. So I will make it here. I will enter here 75. I will set this age. It will become 75. And again I will set this age. It is also 75. Now on this side triangles are removed. Okay. Now maximum triangles are removed. I'm again we can reduce it. Now here 75. We can reduce to 74, 73. Okay. Some triangles are there here. Okay. I will make it. Okay, I will make it 72. Here also I will make 72. Okay. And it will change both sides. You can see here now you will not get any triangle in this direction. Okay. Now here there is one triangle. It is on this side. Now here you can check the number of elements. There are 14. Here you can check there are 13. I will increase one by one. Now you can see here all triangles are removed from here. Okay. Now this 14, when we adjust, it will move to this 14 also. That means this number and this number will be same if it is a proper geometry. Now here you check on, okay, I will check on this side 10, at this location 14. Okay, I will increase this also. I will make it 14. Okay. Now here 16, I will make it 14. Here it is 14. Or now this is a circular region, therefore we cannot remove all the triangles. If you want to remove, you mesh the surface first and then you go for what we can say solid. Okay, I will make 15 here because there was triangle on edge. That triangles you have to remove. Now on this edge there are 30 elements on this edge and 30. Here on this side we cannot modify. Here you can see this in bracket. Why? Because this part is already meshed. This part is already meshed. Okay, I will make it 30 and say mesh. Now you can observe the mesh. Now I will hide the geometry. You can see here how you will get the good quality elements, good quality mesh. These triangles we cannot remove. Why? Because we don't have that much control. If you want to remove, you first mesh the surface and then you go for solid solid conversion. Okay, have you got it? Have you got it? See here, it is very interesting thing. Indrajit Mohiti, have you got it?
Yes, sir.
Will you do like this? Now
Yes, sir.
after doing this, what you have to do? You uh, delete the two-dimensional elements which we have created here. Now how we can search the two-dimensional elements? Now for searching the two-dimensional elements, what you have to do? You go to the, you can, okay, I will show you first mask by mask. Mask elements by config. Now the two-dimensional elements which we have created, that elements are of chord elements. Okay, so we can remove that chord elements by config, and their configuration is chord 4. Okay, now I have selected chord 4 element for mask. Now I will click on select entity. You can see here the elements on this face are selected. Select the mask and reverse. Okay, these are the two-dimensional elements. You can see here. These are the two-dimensional elements. These two-dimensional elements are not required for our analysis because our geometry is 3D geometry only, and there is no 2D part. So these elements we have to delete it. Okay, now how we can delete it? I will go to the return, delete elements display, and say delete. Return from here and click on unmask all. You will get only 3D element. You will get only 3D element. Okay, after that what you have to do? You check the faces. You check the faces. Okay, now I'll go to the tools, faces, select the elements displayed, and find faces. Okay, find faces. Now here face component is added here. Now I will hide the 3D elements. Now you have only 2D elements, you can see here. Now if I mask this portion, I want to mask these elements by face. Now you can see here it is complete hello on this side also. If I mask this elements by face, you can see here. Where is this? If there is a this is hello, then there is a proper connectivity. You can see here. Where is this? There is a proper connectivity. Okay, that means your solid elements are inside this. There is no any discontinuity in the solid elements, and this is the beauty of the solid map options. It will not create the faces. It will not create the faces. That means it will avoid the discontinuity. Okay. Now I will delete this. Delete this. Now see here again, if you want to check the elements, what you have to do? You run the pre analysis. Pre analysis. Okay. Now how you can do this pre analysis? I will show you. For that purpose, you create the material for it. You create the properties for it. Then you create the load steps, load collectors. Okay. Now I will go to the material. I will make it steel. Okay. And type is isotropic. I will define the color. Okay, and say card image mat 1. Click on create it. Now I will define the steel. What happens? Mat 1 card image. Create edit. Material is already created. Return. I can do from here also. Now I want to enter here E. Next new. You can see here. I can enter E. Next, enter here 0.3 and press enter key. This one. Okay. Now this material is created here. You can see this properties of the material. Here, this is a E, this is a Poisson's ratio, this is a density. Okay. After doing this, go to the properties. Properties. Now here I will set the solid properties. Next, I will define the color as this one. Type is 3D. Card image. P solid. P solid. Material which we have created. Okay. And say create. Not necessary to do here. Created it. Okay. Now you have to assign the properties to this component. Now go to the component, update, select the component, select it. Now it has no card image and properties, select the solid and update. Okay. Now you can see here, if we display by properties, it will be changed. It will show the color of properties. Color of properties. Okay. After that, you define the load collector. Load collector. Now here you write the EIGRL. This is a card for this is a card name for eigenvalue model analysis. Okay. Now you can define the color. Not necessary to define color here. I will go to the
हॅलो
card
सर,
image.
प्रेझेंटेशन
Yes.
दिसणं झाले स्क्रीन.
दिसून झाल्या.
हा स्क्रीन दिसणं झालं सर. मी लेफ्ट होऊन जॉईन झालो सर, तरी पण दिसेना सर.
Okay, I will check it. It is visible from my side.
Now it is visible sir.
Okay. Now card image is EIGRL. Okay. It is for model analysis or it is a pre-free run. Now click on create edit. Now in model analysis, what we are doing, we are checking the connectivity. And for connectivity, we have to enter the initial frequency and final frequency. Now I will enter here. What happens here? Okay. Here it is 0. V2 is I will check here. Okay, I will do here. Return from here. Now initial frequency is 0. Final frequency is suppose 1000 and 1000. Number of modes suppose 4. Okay. Number of modes of vibration, that is here we are checking the amplitude ratio, that is modal analysis we are doing here. Okay. Now this is for EIGRL card load collector. Now not necessary to fix anything, not necessary to do anything. Okay. Now go to the analysis. Next, go to load steps directly. Load step. Here I will give the name free run, free, and in place of linear static, you go to the normal modes, and click on method struct. Select EIGRL card. Okay. SPC is not required, MPC is not required. We are not fixing anything. Say create. Load step is created. Next one, I will save it. File, save as model, and I will save it in folder. Okay, I will give the new folder, save, over. Now click on OptiStruct. Here export option is all, run option is analysis, and click on OptiStruct. It will start the running. If there is a discontinuity, then it will be detected by this analysis. It is solving. And here in industry, this is a practice. After every, that means after finalization of the mesh, that means after developing mesh, then you have to check it for pre-run, pre-analysis. Okay. Now it is taking time because number of elements are more. Okay, analysis is completed. Now go to the results. It is the message of graphics card. Okay. Now you see here don't go for any results. This is a frequency. This is a frequency. You check only animation. Okay, we will see the deformation. Eigenvalue mode. Apply. Now you can see here, these are the modes. Okay, this is corresponding to the first mode. You can take anything you can see here. And if we see the animation, you can see if whole part is displacing as a single part, that means here in different modes you will get the different deformations. Already I have explained in the dynamic analysis in theory. Whole part is displacing at a time, then there is a proper connectivity. You can check in any mode. Subcase is this one. Here. Next, 4 modes we have just taken. You can see here. Okay, whether this animation is visible or not. Whether this animation is visible. I will increase the scale. You can see here. It is going to displace as a single part, and it is a pre-run. And in each mode, you will get the different deformation. This is the first mode. This one is second mode. This one is third mode, and this is a pre-vibration. Pre-vibration. You can see here. I will reduce the scale. You can see this one. Okay, if it is moving as a single part, then there is a proper connectivity, and this is the one check for meshing. Okay, do you agree with this? This is one check for meshing. Any doubt here? If you have doubt, you can ask me. If you are not get any concept, that means if you are doubt in any concept, then you can ask me. I will explain that concept. I will explain theory of that concept also. Kunal Patil, if you are doubt in any concept, you can ask me. I will explain the theory of that concept also.
Okay.
No? See here, this is a pre-vibration. Pre-vibration, we have solved the spring mass system. Spring mass system, am I right? And in spring mass system, we have seen how these masses are moving. But here, we have not taken spring mass system. What we have taken? We have taken the uh, complete solid body, and that solid body under pre-vibration is displacing like this. Okay, we agree with this. These are the mode shapes, and these mode shapes are under pre-vibrations. Okay, and that you have to check for checking the connectivity of the elements. Okay, now I will close this. Now I will show you other options here. Now I want to modify the elements. Okay, modify the elements. You can modify it. Now I will go to the 3D. I will delete the elements. Okay, I will delete from one component and I will show you. Okay, I will delete all the elements. Delete. Now this is a geometry. This is geometry. You can see here. Here there are different options in solid map. One is general. One is line track. I think line track I have explained. Linear solid is also explained. See here, these options are same to each other. How we can do this, I will show you. Now I will show you general. Okay, general. Now if I select the source surface is this one, not this one, and destination surface as this one. Okay, and along the geometry, if I select the lines, this line, this line, this line, sorry, not this, and this line, and say mesh density is 10. In place of 10 I will make 8 5. Say mesh. Now it will not mesh. Why? Because we have not elements for the reference. So here it requires the elements for the reference. So first we have to do the 2D meshing of it. Now go to 2D, auto mesh, this surface. I will select here surface, this, sorry, this surface, and say mesh. Okay, now I will not go for the removing triangles. I will just want to show you the option. Okay, return from here. I will go to the 3D solid map, general. Okay, now here I can do the meshing without source surface. Why? Because I have elements on the source surface. So when we want to do the meshing without source surface, you can select none here. Okay, and if it is a simple geometry, destination surface is also not required. Okay, now I will select the elements, these elements by face. Okay, and along the lines you can mesh along the nodes, you can mesh along the lines, you can mesh along the surface also. You can see here there are different options. You can mesh along the surface also, you can mesh along the nodes also, you can use mixed also, that is line, node and lines. Okay, now here I will mesh along the lines, this, sorry, this, okay, okay, this line, this line, this line, this line, and say mesh. You can see here it has created these elements. Okay, on the surface. Are you getting this? In this way we can do the meshing, and again I will explain remaining options at the time of next practical. After, now time is over, so I will stop here. I will explain remaining options and I will take the one exercise in this. Okay, now we can stop here. If you have doubt, you can ask me.